Okay, so we have two problems here where we're going to simplify expressions involving exponents, and notice here in the instructions we don't want any negative exponents. So we're going to make sure that all exponents are positive. We're going to use these properties that you viewed in the previous videos to simplify these problems. So now, a couple hints. One thing is that I'm going to follow order of operations to a certain extent. Because it's all multiplication, I can actually not necessarily follow it, but it's a good rule of thumb if you're not sure how to do the problem. So if you notice here we have parentheses, so I'm going to look inside the parentheses and say, hey, look, is there anything that I can reduce or simplify? Nothing. So now that I know that there's nothing I can reduce there, order of operations tells me to look at exponents. Well, I have an exponent here outside of this parentheses, and I'm thinking, hey, I have this power property with this exponent on the outside. So I'm going to go ahead and I'm going to start by reducing this piece right here. I'm going to leave this piece alone because that's multiplication with the piece with the exponent outside of the parentheses. So our power property states that we're just going to go ahead and basically, for lack of a better term, I'm going to take this 2 and multiply it with all of the exponents on the inside. Remember, this 2 has got a 1 right here. The other thing that I want you to notice here is that this guy right here, this 2, is negative, and it's inside the parentheses. So we have to be careful with that. If the negative was on the outside, the square goes to what's inside the parentheses, so it would stay negative. Okay? So this would be the same as a negative 2 times 2, which is going to be negative 4. If the negative is on the inside of the parentheses, it's going to be the same as negative 2 times negative 2, which is a positive 4. So we need to be careful with situations like that. Okay? So now we've identified that the negative is on the inside, so we know it's going to go away. So the first thing that I do to make sure that I don't make any mistakes is I'm actually, when I rewrite this, I am going to take just the 9a squared b cubed. I'm going to rewrite it. I'm going to keep this guy in parentheses just to separate it, and I'm going to get rid of that negative because I know it's going to turn positive. Okay, so now we have the 5 and the 2, and we know that those are going to be multiplied. So that's going to be a to the 10th. We're going to do the same here with this guy, and so that's going to give me b to the negative 6. Okay, great. Now, the other thing that I might want to do, and it doesn't really matter the order that we do this, but we know right here this b and this b are going to be combined. It's kind of like a chess game. If you play chess, I know what's going to happen here even before I do it, so I understand what my answer is going to look like. And it's important to be able to see those kinds of things with these types of problems, especially the difficult ones. And so what you might want to do is you might want to wait to deal with the negative exponents until the very end. And that way you're not flipping things and getting confused as to what order I should be in. When you get more comfortable with these problems, go with it and just do what's comfortable with you, for you. And so now I'm going to go ahead and just to add an extra step here, I'm just going to simplify, remove the parentheses. I turned 2 squared into 4. And now I'm going to take all my like terms and put them together. So I have a 9 times a 4. I have the a's. And I have the b's. And so all these guys are going to be combined. And so the next step would be 9 times 4, which is 36. And then I have a squared times a to the 10th. You don't have to write this all out. I'm just showing this to you so you see all the progression of the problem. And then b cubed times b to the negative 6. So when we have exponents that are being multiplied that have the same base now, what do I do with their exponents? I add them together. So I have 36, and I have a 2 plus 10, which is 12. and b cubed times b to the negative 6. So 3 plus a negative 6 is going to be negative 3. So now at the very end, what am I supposed to do with the negative exponent? Now this is the only variable with a negative. So everything else is going to stay. So I'm only going to flip the b. I look to see at the very end if I can reduce anything. There's no other numbers that can reduce 36. There's no other a's and there's no other b's. And I have no negative exponents. So this guy right here is my final answer. Okay, so let's go ahead and look at the second problem here. And with the second problem, I have 2z times quantity of 3x squared times quantity of 5z to the negative third. So this is actually possibly a little bit easier than the previous example. I notice here that there's no exponents on the outside, so there's no power property that I have to worry about. So what I'm going to do is I'm just going to look at like terms. And so I have all these constants together. So in my head, I'm going to do 2 times 3 times 5. So 2 and 3 is 6. 6 and 5 is 30. And we generally write them in alphabetical order. I have an x squared that's being multiplied. There is no other x term. And then I have a z to the first times z to the negative 3. So I have terms that have the same base. So what do I do with their exponents? I add them together. So I have a 30x squared times z to the negative second. Well, because I have a negative exponent, I have to flip it. And remember, this is the only one that gets flipped because this is the only variable that has the negative exponent. The 30 and the x stay at the top. Nothing else can be reduced. That is my final answer.